My best guess for how this will manifest is that prices will drop.
Elon Musk believes that in an age of advanced artificial intelligence, almost everything could eventually become virtually free. It's a powerful vision of the future. But in this video, I want to test if that is really true and what we can actually expect. Today's typical middle-class family feels their budget being stretched to the absolute limit. They're facing an affordability crisis that feels impossible to escape. So, will technologies like AI and robots finally give them some relief in the coming decade? We are going to give you a data-driven answer. If you look at how prices have actually evolved over the last 50 years, a total price collapse by the late 2030s seems highly unlikely. But our research reveals a different story. By 2039, your household budget will be structurally unrecognizable. Not because everything becomes cheap, but because the biggest taxes on your life, mobility, energy, and routine services, are about to experience a profound decoupling from human labor. To find the truth, we have to look past the software we download and into the physical world we actually live in. We've built a model using current labor share data and manufacturing learning curves to map exactly which parts of your budget AI will delete and which ones will remain stubbornly, painfully high. This isn't about utopian dreams, it's about the raw math of the next 13 years. Let's look at the data.
I've been getting a lot of questions about how AI and robotics will impact prices. I understand it because we definitely have an affordability crisis at the moment. You also hear people like Elon Musk saying we'll have abundance and everything will be virtually free.
Digital products are fundamentally different from physical goods. Once the code is written, the cost of producing one more copy is almost zero. And in the age of AI, even the cost of writing that code is collapsing. What used to require teams of engineers can now be generated with a prompt. This isn't a future scenario, it's already happening. AI tools that just a year ago cost $20 per month now exist in free versions. The lower tier models become free, and the paid tier simply shifts to a more capable system. The nominal price may stay the same, but the capability you receive increases dramatically. In real terms, that's a price decline, sometimes by 80 or even 90% in just a few years. We've seen this pattern before. In the early 1990s, professional design software like Photoshop cost hundreds of dollars upfront and offered a fraction of today's functionality. Today, even a free tool like Canva Basic can do more than early versions of Photoshop, and it's accessible instantly from a browser. The price didn't just fall, the capability per dollar exploded, and by 2039, this dynamic accelerates. Tools that today feel extraordinary, AI systems capable of generating an entire film from a single prompt, will likely be widely accessible at little to no cost. Not because companies are charitable, but because digital supply explodes. And when supply explodes, prices compress.
Consumer electronics, it's the same, right? The direction we've been seeing in the 2020s will continue here in the 2030s. And I definitely think that consumer electronics will fall by another 50% in the next 10 years.
Some prices in the 2030s will not drift down, they will collapse. To understand why, we need to start with something very simple: Moore's law. For decades, computing power roughly doubled every 18 to 24 months. In practical terms, that means the cost of a fixed amount of compute fell by about 30 to 40% per year. Over 13 years, that compounds to roughly a 97 to 99% decline in cost per unit of compute. Now here's the important part. AI inference has recently improved even faster than Moore's law. Between 2022 and 2024, the cost of running GPT-3 level models fell by more than 99%. From 2024 through 2026, effective cost per useful output continued declining as hardware improved, models became more efficient, and competition intensified. So if AI inference merely follows Moore's law from here, say 35% improvement per dollar per year, that implies roughly a 99% additional decline in cost per unit of capability by 2039. That's not speculation, that's compound math. Now translate that into something tangible. Today, generating a high-quality AI video clip consumes real compute and subscription limits. By the late 2000s and 30s, the same nominal cost could generate hours of comparable or superior output, not because everything becomes free, but because cost per finished result collapses. And we've already seen this pattern before. Take smartphones. The iPhone X, released in 2017, used the A11 chip, delivering roughly 600 gigaflops of compute. The 17 Pro exceeds 3 teraflops. That's more than a 5-fold increase in raw processing power in under a decade. If you hold price constant and increase capability 5-fold, the implied price per unit of performance has fallen by roughly 80%. But it doesn't feel 80% cheaper, because quality increases mask price deflation. The same is true for televisions. Quality-adjusted TV prices have declined roughly 10 to 14% per year for decades. By 2039, TVs are likely to fall another 75% in price compared to today, and that before factoring in resolution, brightness, energy efficiency, and smart capabilities. Now consider wearables. An Oura Ring today costs roughly $300 to $400. It tracks sleep, heart rate, and some biometrics. By 2039, if sensor costs follow electronics trends, say 50 to 70% lower hardware cost, and AI capability follows a more like trajectory, the device may not just be cheaper. It may provide continuous predictive health modeling instead of passive tracking. Even if the sticker price only falls 50%, the cost per unit of health insight could fall 80 or 90%. That is the pattern. In electronics and AI-heavy categories, nominal prices may not collapse to zero, but price per unit of capability is likely to fall 50, 75, even 95% in some domains. That is where the real price shock of the 2030s will occur.
Unfortunately, we see housing costs as pretty stubborn. If we look at construction costs, I think we are into the late 2030s, where we see a cost reduction of maybe 20 to 30%, so not that dramatic. And it really depends on the land value, whether it's a cost reduction at all.
So if land value is such a big part of the equation, the obvious next step is to look at where things actually stand today. Let's take two very different parts of the USA, Manhattan and Dallas-Fort Worth. In 2025, the median apartment price in Manhattan is about $1.125 million. In Dallas-Fort Worth, it's about $375,000, and the difference becomes even clearer. When you look at price per square foot, Manhattan, roughly $1,629 per square foot. Dallas, about $185. That's about a 9-fold difference. It's not because Manhattan apartments use 9 times more concrete, it's because land is scarce. 2 decades ago, land already represented about 67% of home value in New York City, compared to about 46% in Dallas. In Manhattan today, the effective land and scarcity component is likely even higher. So now, fast forward to 2039. What could realistically move these prices? Let's start with technology. Even if modular construction, robotics, and AI reduce building costs by 10 to 20% in real terms over the next 13 years, that only affects the structure portion of the home. If construction represents maybe 20% of total value in Manhattan, a 20% drop in build cost translates into maybe 4% of the total price. In Dallas, where structure may represent closer to half of total value, the impact might be closer to 10%. That matters. But it's not what will dominate the market, but interest rates will. Over the past 20 years, the lowest mortgage rates Americans experienced were roughly 2.7% in 2020 and 2021. That's our real-world floor. Now imagine mortgage rates fall from around 6.5% to 4.5% over the next decade. That's just a 2-point drop. On a $900,000 loan in Manhattan, where that reduces monthly payments by over $1,000. On a $300,000 loan in Dallas, where it reduces payments by roughly $400. That's about a 20% swing in affordability. Construction technology is unlikely to create a 20% drop in prices. Interest rates can create that instantly. Now here's the important nuance. If rates fall, prices often rise. So affordability might not improve very much. You could see home values go up 15 or 20%. Simply because financing becomes cheaper. So when we think about 2039, we have to separate price from affordability. Prices could rise, monthly payments might stay similar. Now at demand, we already know remote work increased from roughly 5% of workdays before the pandemic to around 20 to 25% in recent years. The big question is whether that becomes permanent. If it does, dense urban cores could see slower demand growth, but history suggests caution. During the financial crisis, New York prices fell about 18%. Painful. But not structural collapse. For Manhattan to fall 40% or more in real terms, you would likely need a combination of high interest rates, persistent remote work dominance, and weaker global capital flows. Possible. Not the base case. On the other side, could Manhattan be up 200% by 2039? Nominally, maybe under very high inflation. But in real terms, that would require nearly 9% annual growth for more than a decade. Historically, that's extreme. So the most realistic range, absent major shocks, is something like flat to moderately up in real terms for land-constrained cities that remain globally attractive, and flat to slightly down in real terms for areas with abundant land and elastic supply. Dallas-Fort Worth is projected to keep growing toward roughly 12 million people by 2050. So demand may remain strong, but outward expansion limits scarcity. Now what about rent? Low interest rates tend to push asset prices up. They don't automatically reduce rents. Rents track local income and supply. In Manhattan, if high-income workers cluster and supply remains constrained, rents likely stay elevated in more elastic metros. If supply expands and income growth slows, real rents could flatten or decline modestly. So where does this leave us? There are many variables we cannot know. Inflation, interest rates, the permanence of remote work, the scale of AI-driven labor disruption. But if we rank what will most likely move housing prices between now and 2039, well, technology is not at the top. Interest rates, and here people want to live matter more.
So I think a big one where quite little has happened in the last 25 years is transportation or mobility. And I think we'll see quite a lot happening already in the early 2030s. I think autonomous driving will gain momentum, so will robotaxis, and with scale, the prices will fall as well. See, I think we can expect the average family to maybe spend 50% less on transportation.
We touched on how transportation costs could drop by as much as 50% for some families. Let's get into the math and see exactly how that plays out. In 2025, a typical suburban American family with 2 vehicles spends somewhere between $19,000 and $20,000 a year just to own and operate those cars. That includes depreciation, insurance, fuel, maintenance, and financing. And most of that cost isn't fuel, it's depreciation, the quiet tax of ownership. Now fast forward to 2039. Electric vehicles will be cheaper to build, batteries will cost a fraction of what they did in the 20s, maintenance drops, and insurance gradually restructures as autonomous systems get safer. If you keep 2 vehicles in your driveway, you might save 15 to 25%. That's meaningful, but it's not transformational. The real shift happens when you redesign your life. By the late 30s, mature autonomous fleets in major metros could operate at around 35 cents per mile in dense corridors. That sits within long-term modeling ranges of roughly 25 to 60 cents per mile, depending on scale and density. Now combine that with behavioral change. Hybrid work reduces commuting. Hybrid schooling cuts daily drop-offs. Delivery handles a portion of errands. Instead of driving 20,000 miles a year across 2 vehicles, a family might only need 8,000 miles of actual mobility. At 35 cents per mile, that's about $2,800 in annual movement. Add a premium 2-week road trip rental, add delivery fees, add the occasional larger vehicle. You land somewhere around $6,000 to $7,000 per year. From a $19,000 baseline, that's a 60 to 70% reduction. Not because cars disappear, because ownership disappears. Now, geography matters here. In Manhattan, this transition is almost obvious. Many households already operate without private vehicles, and by 2039, full subscription-based mobility is highly plausible. In Dallas-Fort Worth, it's more conditional. Inner corridors with density and strong fleet coverage could realistically support 0-car households. But outer suburbs will likely stay 1-car households for much longer. So this isn't automatic. Hold on to your truck and your daily driver. Savings are modest. But shift from a commute economy to an experience economy, and transportation becomes a variable cost instead of a fixed one. And that's the deeper story. The technology makes it possible. Adaptability makes it meaningful. In the turbulent decade ahead, transportation doesn't just get cheaper, it becomes optional.
Human services, I don't think they'll fall at all. I think being serviced by a human will be a luxury good. But it is unpredictable because there could also be a lot of humans forced out of their current jobs because of automation, and then they'll move into human services. So I'm not quite sure on that one, but I think in general it will not fall. I think the society will be more abundant, and time will be one of these things that will be expensive to buy from humans.
The real transformation here isn't falling wages. It's declining demand for routine human hours. The price per hour may hold, but the total hours purchased may shrink dramatically. To keep this realistic, we need a model family. So let's assume a 2-income household in Dallas-Fort Worth, earning about $120,000 per year, 2 school-age children, homeowners, time-constrained but not wealthy. In 2025, this family might reasonably spend around $12,000 per year on outsourced human services. That includes roughly $3,500 on bi-weekly cleaning, $1,500 on lawn and landscaping, around $3,000 on tutoring or enrichment, $1,200 on tax and financial prep, $800 on occasional legal or advisory services, and about $2,000 in paid home maintenance labor, $12,000 before we even talk about childcare or healthcare itself. Now here's the key question. Will those human wages collapse by 2039? Most likely, no. Haircuts still require dexterity, childcare still requires trust, skilled trades still require presence. Even if AI advances rapidly, wages in these fields are anchored by minimum wage laws, labor supply, and social trust. So the real shift is not cheaper humans, it's fewer human hours purchased. Let's separate what is technically possible from what is socially likely. Technically, by 2039, AI tutoring systems will almost certainly be capable of handling routine subject instruction. Tax preparation and legal drafting can be largely automated. Lawn mowing is already automated today, and cleaning robots will likely reduce the frequency of human housekeepers. But adoption depends on preference. Some parents will still choose human tutors, some households will prefer monthly human cleaning, some will never trust automation for certain services. So let's model 2 scenarios. First, low substitution. This is the family that adopts AI as an assistant, but not as a replacement. Cleaning frequency drops slightly, tutoring hours are reduced but not eliminated. Tax prep is AI assisted, but still human reviewed. Lawn mowing is automated. In that case, annual savings might reach around $4,000. $12,000 drops to roughly $8,000. Meaningful, but not transformative. Now let's look at high substitution. This family adopts AI-first systems. Wherever routine human hours are involved, tutoring becomes mostly AI-driven, with occasional human mentorship. Cleaning shifts from bi-weekly to monthly, lawn care is fully robotic, tax and financial admin are almost fully automated, and predictive diagnostics reduce unnecessary home service calls. In that case, savings could approach $7,000 to $8,000 per year. $12,000 drops closer to $4,000. That's a 60% compression. Not because wages collapse, but because the number of paid human hours collapses. And that distinction matters. If you do nothing, savings are minimal. If you selectively adopt AI in high routine categories, savings are moderate. If you go fully AI first wherever trust and regulation allow, savings become significant. But unlike transportation, this is not a structural collapse category. Human services don't disappear. They stratify, routine becomes automated, human presence becomes intentional and often more premium. So by 2039, the question isn't whether humans get cheaper, it's how many human hours you still choose to buy. And that choice, more than the technology, determines how much you actually save. Let's now turn to food. Unlike transportation or electronics, food is structurally more resistant to collapse. In 2026, the median American household spends roughly $10,000 per year on food. For an upper-middle-income suburban family earning around $120,000, that number is closer to $14,000 to $16,000 annually. Groceries account for about $8,000. Dining out and takeout, roughly $4,500 to $5,000. And delivery, which has become its own category, adds another $1,500 to $2,000 on top of that. Now here's the key structural insight. When you break down the food dollar, only about 30 to 35% of total cost is directly labor-driven. The rest is commodities, processing, energy, real estate, packaging, logistics, regulatory compliance, and margin. Yeah, that means even aggressive automation has limits, but it does not mean nothing changes. By 2039, agriculture will be more autonomous. Precision spraying reduces fertilizer use. AI forecasting reduces overproduction. Cold chain logistics cut spoilage. Today, 4 to 6% of retail grocery cost is pure waste. If that waste is cut in half, households could save perhaps $75 to $150 per year simply from better inventory flow and smarter purchasing. That's real. But it's not a revolution, because farm-level labor is only about 12 to 18% of farm cost, and farm cost is only part of retail pricing. Grocery prices. In real terms adjusted for inflation, grocery prices by 2039 could decline modestly. Perhaps 3 to 6% in a base case automation scenario. Most of that comes from waste reduction, AI-driven meal planning, more efficient distribution, and limited gains in processing automation. But wages in logistics and energy costs will likely offset part of those gains, so the realistic expectation is not dramatic deflation, it is inflation resistance. Automation prevents 1 to 2% annual cost creep, delivery and fast food. Now this is where automation is most visible. Today, delivery includes a heavy labor stack, courier wages, tips, platform commissions, service fees. If autonomous delivery scales and robotic kitchen stations reduce back-of-house labor, the delivery penalty shrinks. In a competitive market, that could reduce delivered meal costs by perhaps 5 to 15% in real terms. Not 40%, not collapse, but meaningful compression. Delivery only, automation-first chains could operate at structurally lower cost, especially if they eliminate dining rooms and prime real estate. Whether those savings pass to consumers depends on competition. Automation lowers cost of production, competition determines price, casual and fine dining. Sit-down dining is more resistant. You are paying for real estate, you are paying for ambience, you are paying for service. Only a small fraction of that is automatable without degrading the product. Casual dining might see 1 to 3% real compression. Fine dining is even more resistant. In fact, in a world where routine food becomes more automated, fully human dining may become more premium. Prices there may actually rise in real terms. Let's bring this back to the household. In a moderate automation scenario by 2039, grocery prices may decline 3 to 5% in real terms. Dining out may compress 2 to 5%. But the real swing factor is delivery. If a family relies heavily on takeaway and embraces full automation, they could see meaningful savings as autonomous logistics remove tips, platform fees, and much of the labor stack. In that case, annual food savings could approach the higher end of the range, perhaps $800 to $1,000 per year. But for a family that prefers sit-down dining and rarely uses delivery, savings may be modest, closer to a few $100s annually. The grocery basket anchors the system. It moves, but it doesn't collapse. So the total effect depends less on technology and more on behavior. Food doesn't implode the way transportation might. It compresses slightly. It stabilizes. It stratifies by experience. Routine food becomes optimized. Human-crafted food becomes more intentional and often more premium. Automation does not make food cheap, it makes food efficient. And how much you save depends on how automated your lifestyle becomes.
Energy, I think this will depend very much on the household, but we can already see it now. Solar energy, for example, can decrease costs quite a lot in certain areas of the world.
So let's break this down in real numbers. In 2026, a typical suburban household in a high energy use US state living in a 2,000 to 2,500 square foot home spends roughly $3,000 per year on electricity and natural gas combined. That covers cooling, heating, appliances, and increasingly electric vehicle charging. Now let's look at what changes by 2039. First, efficiency alone. Better heat pumps, smarter load control, and more efficient appliances can reduce total energy use by about 10 to 15%. That lowers the annual bill from $3,000 to roughly $2,600 to $2,700. That's the low adoption case. Now add rooftop solar. By the late 2000s and 30s, installation costs could fall significantly and panel efficiency could rise toward 27 to 28%. A properly sized 12 to 14 kilowatt system could offset most of a household's annual electricity use. Without storage, operating energy costs could fall to roughly $1,400 to $1,600 per year. That's a 45 to 55% reduction compared to the 2026 baseline. But the household still buys power at night and during seasonal shortfalls. Now add storage. A 15 to 20 kilowatt hour battery wall allows excess daytime solar to be stored and used during evening peak hours. Add one electric vehicle with vehicle-to-home capability, and the system gains access to over 100 kilowatt hours of additional storage capacity. At that point, most retail electricity purchases are eliminated. Annual grid purchases could fall below $1,000 per year. In aggressive adoption scenarios, closer to $500 per year. That's a 70 to 80% reduction in operating energy purchases, but this requires investment. A full system solar battery wall bidirectional charger could cost $20,000 to $25,000 installed by the late 2000s and 30s. If financed over 20 years at 4 to 5%, that adds roughly $1,200 to $1,400 per year in capital cost. When you include financing, total annualized energy cost lands between $1,500 and $1,800 per year. Compared to the original $3,000 baseline, that's a 40 to 60% long-term reduction. Not free energy, not collapse, but significant compression. For households that do not install solar or storage, savings remain modest, roughly 10 to 15% from efficiency alone. For apartment residents, savings are typically smaller, often 10 to 25%, depending on access to community solar and grid pricing. So the price story is straightforward. Efficiency alone trims the bill slightly. Solar cuts it roughly in half. Solar plus storage can reduce operating purchases by up to 80%. When capital costs are included, the realistic long-term reduction is closer to 40 to 60%. Energy does not disappear as a cost. But by 2039, households that invest in generation and storage can materially reduce what they pay each year.
So education is a really tricky one. I think we'll start to see options in the early 2030s with AI education. But it really depends, right? If you want that Harvard brand, I don't see any cost reductions for you. But if you stay flexible, there could be a cost reduction. On the other hand, of course, you could say, well, education in many countries is paid by the state already with like public schools and public universities. So maybe it will be less of a cost via the tax.
Let's take a closer look at the costs of education for the average family. Education behaves differently from most other household expenses. In the US, more than 90% of kids attend public schools from kindergarten through 12th grade, and those schools are funded primarily through state and local taxes. Average public spending is roughly $17,000 to $18,000 per student per year, but the direct out-of-pocket cost for families is much lower, typically $1,000 to $2,000 per child annually for supplies, activities, and technology. Artificial intelligence may improve productivity in the classroom. AI tutors can assist with grading, tutoring, and personalized instruction. But because public education is already funded through taxes, the direct financial benefit to families will likely be small. Some households may adopt AI-assisted homeschooling or hybrid learning models. However, these options typically cost $4,000 to $10,000 per child per year, which is higher than public school. For most families, that would increase costs rather than reduce them. As a result, the main financial pressure in education is not K through 12, it is college and university. For a typical suburban American household earning around $120,000 per year, the out-of-pocket cost of raising 2 children through public school and a 4-year college degree is approximately $200,000 in today's money. The majority of that cost comes from tuition, housing, and campus infrastructure during the university years. Artificial intelligence could change the economics of higher education in several ways. One path is the traditional elite university model. Institutions like Harvard, Stanford, and MIT derive value from brand, research, and campus networks. AI may reduce teaching costs internally, but the scarcity of these institutions means prices are unlikely to fall significantly. A second path is the hybrid university model. Students complete a substantial portion of coursework remotely using AI-assisted learning systems, then attend campus for shorter in-person programs. Reducing campus time lowers housing, facilities, and staffing costs. Under this model, total university costs could fall by 30 to 40%. A third path is AI-first education. Students build portfolios of certifications, projects, and verified skills through digital platforms rather than attending a traditional 4-year campus program. In fields like technology, finance, and business, this approach could reduce total education costs by 50% or more. For a household with 2 children, that creates 3 possible outcomes by the late 2000s. The traditional university path may still cost around $200,000. A hybrid university path could reduce that to roughly $130,000 to $140,000, and a largely digital education pathway could reduce total costs to around $100,000. Education costs, therefore, do not collapse universally. Instead, the cost increasingly depends on how much campus infrastructure, brand prestige, and in-person instruction families choose to purchase.
So healthcare, in terms of the diagnostics, I think that can be a lot cheaper. So, you just don't need that doctor visit because you will have the means to do the tests at home, and you will have variables. So I think that can decrease pretty early in the 2030s, around 40 to 70%. In terms of treatment and care, I actually see that increasing before it might fall in the late 2040s. So it's a very stubborn cost. The same goes with childcare, so I don't see robots taking care of our children anytime soon. So that is definitely a stubborn cost. I think maybe in the late 2040s we could see robots take some of the functions. And the same pretty much goes for elder care. So we will not see this impact before the 2040s really.
Healthcare is one of the few categories where technology doesn't necessarily make things cheaper for families. Today, roughly 40 to 45% of healthcare spending goes to diagnostics and consultations, basically finding out what's wrong. The remaining 55 to 60% goes to treatment, drugs, procedures, and hospital care. Now, AI and home diagnostics could significantly reduce the cost of that first part. Fewer doctor visits, fewer unnecessary tests, earlier detection, all of that may bring down the cost of diagnosis. But treatment is where most of the money actually goes. And as medical technology improves, societies tend to spend more on treatment, not less. Historically, as countries get richer, they devote a larger share of their economy to healthcare. Why? Because better treatments make it possible to treat diseases that were previously untreatable. So while AI may create real savings on diagnostics, the most likely outcome is that families will simply spend those savings, and then some, on better treatments. For our model family, that means healthcare spending in 2039 will likely be higher than in 2026, whether through insurance premiums, out-of-pocket costs, or taxes. Earlier, we looked at digital goods and services, where technology tends to drive costs down. Entertainment partly follows the same pattern. In the mid-1990s, a single movie on VHS typically cost about $20, roughly $40 in today's money. Now, a streaming subscription of around $15 to $20 a month gives you access to thousands of titles. By the late 2030s, generative AI will likely expand that supply even further, producing personalized movies, games, and interactive media at near zero marginal cost. But for a typical suburban household, spending on digital entertainment is unlikely to collapse. Most families already subscribe to multiple services. Across streaming, gaming subscriptions, and digital media, a realistic household spend sits at roughly $120 to $180 a month, or about $1,500 to $2,200 a year. What changes is not the spending, but the sheer amount of content available. Now, physical experiences follow a very different economic pattern. Concerts, theme parks, and major destinations all operate under strict capacity constraints. There are only so many seats in a stadium, only so many visitors a location can handle. And historically, that scarcity has pushed prices higher. In the United States, the average concert ticket rose from about $26 in 1996 to roughly $136 today, a real increase of more than 170% above inflation. Theme park prices show a similar trend. A ticket to Disney World cost about $35 in 1995, equivalent to roughly $70 today. In 2026, typical ticket prices range from about $110 to $190. So for households, the result is not a clear trend toward cheaper leisure. Digital entertainment becomes dramatically more abundant, but scarce experiences often become more expensive. Economists describe leisure spending as highly elastic. As incomes rise, families tend to allocate more toward experiences, not less. So by the late 2030s, technology may well reduce the cost of everyday entertainment at home. But most families should not expect their total leisure spending to fall. Instead, the mix changes. Abundant digital entertainment at home and fewer, but often more expensive physical experiences outside of it. Let's now circle back to our model family in 2026, a suburban household of 4 earning around $120,000 a year. They own a home, drive 2 cars, and have 2 children, one in public school and one attending a public university. In many ways, this family is a good example of the affordability crisis unfolding across the Western world. On paper, they're solidly middle class, but in practice, they're being squeezed from every direction. To keep things simple, we modeled their lifestyle as a $100,000 annual budget. About $30,000 goes to housing, $18,000 to transportation, and roughly $17,000 to education, while one child is in college. Add food, healthcare, utilities, and a modest amount of travel and entertainment, and the entire budget is quickly accounted for. This stage of life is often the most financially stretched period for middle-income families. After taxes, a household earning $120,000 may take home closer to $90,000 to $95,000, which means maintaining a $100,000 lifestyle often requires some combination of savings, drawdown, loans, or delayed investing. So the key question becomes simple. Will the technologies emerging today actually give families like this more breathing room by 2039? First, let's look at the scenario where the family does not change their lifestyle. They keep the same house, they still own 2 cars, they continue to send their child to a traditional public university, but they do adopt the obvious improvements, switching to electric vehicles, installing solar panels, and benefiting from gradual efficiency gains in areas like food production and logistics. In other words, no lifestyle revolution, just the practical upgrades most households would eventually adopt. So, what would that same lifestyle cost in real terms by 2039? The answer is somewhat surprising. The reduction is very modest, only about 4%, roughly $4,000 a year in real terms. A few categories do improve. Transportation gets cheaper as electric vehicles cut fuel and maintenance costs. Energy bills fall with rooftop solar. Food becomes slightly more efficient through better automation and logistics. But other categories barely move. Housing remains largely driven by land and construction costs. And healthcare continues to edge upward. So for a family that keeps the same lifestyle, technology improves efficiency, but it does not dramatically reduce the cost of living. But what if the family fully embraces the technologies that are emerging today? Instead of simply replacing old systems with slightly more efficient versions, they reorganize their entire lifestyle around the technologies that become dramatically cheaper. In that scenario, the household budget begins to look very different. Instead of spending $100,000 a year, the same family could reduce their annual cost of living to roughly $70,000 in real terms by 2039. That's a reduction of around $30,000 a year, nearly 1/3 of the household budget. The largest change comes from transportation. In 2026, the family spends roughly $18,000 a year operating 2 cars and commuting daily. By the late 2030s, commuting itself may largely disappear. Work, school, and many services move online. Instead of owning multiple vehicles, the household relies primarily on robo-taxis for everyday mobility, with occasional autonomous rentals for longer trips. Transportation costs could fall to around $5,000 a year. Education may experience an even larger structural change. With AI-first university programs, most instruction can be delivered digitally at near zero marginal cost, combined with shorter campus residencies for labs, collaboration, and networking. That shift could reduce annual education spending from around $17,000 to roughly $6,000. Energy also becomes dramatically cheaper. With rooftop solar, home batteries, and intelligent energy systems, households could cut annual energy spending from $4,000 to roughly $1,500. Healthcare may also become more efficient. Continuous monitoring from wearables and home diagnostics allows earlier detection and preventive care. Insurance providers could reward those low-risk households with lower premiums, reducing annual healthcare spending to around $6,500. Housing remains largely unchanged, and food spending declines only modestly through automated kitchens and optimized logistics. But when all of these changes are combined, the result is striking. A lifestyle that cost $100,000 in 2026 could cost roughly $70,000 by the late 2030s. In other words, technology alone does not automatically make life cheaper. But for families willing to adapt to the systems that become more efficient, it can significantly reduce financial pressure and create real breathing room in the household budget. The result is striking. A lifestyle that costs around $100,000 a year in 2026 could cost closer to $70,000 by the late 2030s for families who adapt to the new systems technology makes possible. Now, of course, with the dollar amounts themselves may rise over time because of inflation, but what really matters is purchasing power. If transportation, education, energy, and healthcare become structurally cheaper, families may spend far less of their income on the essentials of life. Technology alone doesn't automatically make life cheaper. But for households willing to adapt to more efficient systems, it can significantly reduce financial pressure and create real breathing room in the family budget. And if you're curious what everyday life might actually look like in that world, you can watch my other video exploring what living in the 2030s could realistically look like.